Beginning tonight, I'm going to review a little bit with functions, as we talked about functions last week because the question came up. What are we doing with functions? Why are we doing functions? How do we do that? And what it really is it's a matter of organizing our code. So in the functions file that was posted up on D2L, you can go and see I stubbed out the functions. Again, the question is, what is this weird word void? That means this function just does what's inside its curly braces, but it doesn't give us anything back when it's done. Some of the functions that we will work with in the coming weeks will give us back things like a number or a Boolean value, so it will tell us if something was true or false. But right now, these are functions that do stuff. As a consequence, they don't give us anything back when they're done. They're kind of selfish that way. They just do their own thing and don't share. But that's all right. We can roll with that. So the first thing that I'm going to do is say I can move my background over to my clear background function. So what I'm showing is how I can take what's in my draw and I will move the appropriate things into the respective fields. Now, updating is where I update values, in this case of my object, which has an X and a Y property. And then I'm going to check its boundaries. We find out if it's hit the top or bottom of the screen. If so, we invert its direction. So that would be in my check boundaries function. And then under display, that's where I have the instructions to draw the stuff that I want to see on screen. So by moving everything out, then I'll uncomment these things that just conveniently happen to be placed there, ready to go. What we will see is I now have a collection of functions that I am able to, got rid of one too many curlies, that I'm able to then reference inside my draw. So my draw is much more concise and organized, and it's calling specific functions. Each function is a single task or operation. Now, you could make the argument that having a function for a clear background, of course, is extra lines of code, but if we view that clearing the background may not simply just be filling it with a background color, but if we go to our older example we looked at where we said, we filled it with a transparent value, and I just draw a rectangle the size of my stage and fill it with a transparent gray instead of just painting with a solid gray, now we have a more complex clearing of the background going on. And this could even be more and more complex as we work with it, but we'll see. That gives the kind of effect. So now the code operates and runs the same as it did before. It's doing the same stuff as having these lines of code in my draw, but my draw is more organized and usable. Another part that becomes useful when you organize your code into functions is there will be times where you will realize you want to reuse things between different projects. And when it's organized into a function, it makes it much easier to grab a complete and concise set of instructions or code and copy it from one project and paste it into another project. At some point, you may even get so fancy that you might even build your own helper library of functions that then you can now use this library of your commonly reused functions from project to project. And a lot of developer teams and programmers end up building their own personal libraries of the functions that they've created, and they find that they're reusing that same function on multiple projects. So instead of retyping it, they just have a library that they import into their project, and now they have access to all of their cool helper functions. Working with loops is going to be something that you will just get accustomed to. Now, sometimes people, when they try to wrap their head around working with a loop, it drives them a little bit batty because of their odd syntax and just trying to figure out how are you using it or what are you doing with it. But the nature of a loop is it's a set of instructions that we program to run a certain number of times. Now we have two primary loop structures that we are going to use. One is the for loop and one is the while loop. Now a for loop has a definite number of iterations or times it's going to run, or in programmer term, execute. How many times will that loop set of instructions execute? A while loop is a great way to cause your computer to crash, because it's really easy to write while loops that are incapable of ever stopping. And when you do that, the program will keep running until it runs out of memory. So if you've ever had programs on your computer where your computer gets hung up and it's stalled and nothing's going on for a while and then it crashes, often it's caught in an unending loop and it can't get out of it. So even professional programmers cause problems like this, because think about all the software you put on your machine. They always crash. Every tool you ever put on your computer is going to crash at some point. So that's programmer error. They should have accounted for all possible ways of interacting and using the program. And if it crashes, that means it's not perfect. So when you are concerned about your code and the problems in your code, remember, even people who are paid professionals still write code that breaks. So that's just something that can, nice little piece of consolation, that what you're doing, it doesn't have to be perfect yet. You're learning. When you're being paid huge sums of money for it, it's expected it won't crash as often. So we're going to start with the while loop because it's pretty straightforward. Now the while loop, you say while, and then inside parentheses you put a condition. And while that condition is true, the lines in between the curly braces are going to keep running. And as they do so, they will keep changing. So we have to set the while loop so that something can now make that condition no longer become true. So in this case, I have while x. While x starts out with a value of 0. And it says while my while x is less than 600 minus w. W is 20. So that would be while the situation is while x is less than 580, right here, 580, draw this rectangle and then make while x get bigger by 25. So the first time through, while x goes from 0 to 25. The next time through, it becomes 50. And then 75, 100, 125, so on, and continuing until eventually it goes from 575 up to 600. And when while x hits 600, this loop stops running. So I'm just going to comment out the other lines here for a moment and run my program. And what you will notice is I got a whole bunch of boxes on screen. And they happened instantaneously because the while loop is going to execute in its entirety before I move to any other things inside my draw loop. So it doesn't do it, oh, I run once, and then I run again, and then I run again. Boom. It goes all the way through. That's what the while loop does. Now there are some programmers that prefer to use while loops in all of their coding, and there are some programmers who prefer to use a for loop in their coding. So I was reading some articles written on blog posts by programmers about you should always use the while loop, you should always use a for loop, and each one touting the merits of which one is better and telling the other one they're wrong. So if the professionals can't agree as to which is the best one or the only one you should use, I mean, one of the posts was the only loop you need in all of your programming. And it was the while loop, and I don't like while loops, I like for loops. So I immediately disagreed with what it said. So I went in with a negative bias to begin with, and after I read the article, I said, I see your point, but I still disagree with you, and I will use for loops as my primary loop structure. So And that's how it is. So that's a while loop. We say what condition, as long as that condition is true, it keeps running. When that condition is no longer true, boom, it's done. So if I change this to 100, so that means we start out at 0, then at 25, 50, 75, 100. So now if I run this, we should see fewer red boxes occur on screen. So we're at 0, then 50, or 25, then 50, then 75, and then on that final iteration, while x became 100, well, 100 is not less than 100, therefore it stopped running, so I got 4 red boxes. That's how my while loop functions. With the for loop, which is different than the while loop, the for loop uses a local variable, which we discussed a little bit earlier. So this local variable of I, which its context is only within this for statement. Unlike my global variables that I have up here, I is the local variable. So the syntax is I say for, and then I make this little local variable, and this serves as a counter. This counter is it's a number that we start out with, and then we just keep incrementing it by a certain amount. Now we have flexibility. We don't always have to start it at 0, and we don't always have to increase it by 1. We could start it at 5, and we could make it increase by 5 each time we go through the loop, so that I would be 5, 10, 15, 20, 25, 30. You could do that, but generally, most people begin their for loops using this counter variable I, and I is used by tradition. Now, normally you rarely will nest more than 3 loops inside each other, because you can, and the next example will show that I have a loop and a loop. And I use J and K. But we normally use I, J, and K as our kind of counter variables. The same way that we use X, Y, and Z for position, we use I, J, K for our counters when we're using loops. This is tradition. I could use any letter I wanted. It doesn't even have to be a single letter, but it usually follows that we would. And within mathematics, I is also often used as our kind of counter value. So I make this local variable I. Then I have the condition at which point it will stop running. So I is less than 20. And then this says each time I go through the loop, make I grow by 1. That's what plus plus does. Now we can compare that to the while, which has a condition, the same way that my for loop has a condition. I increase that some value that can change as part of that. I'm increasing some value that can change. So we can see there's a lot of overlap between a while loop and a for loop. But I like how the while or the for loop defines everything on that first line, so I know my counter I'm starting with, the value that will then make my loop stop running, or how many times I want it to execute, and then how that value is going to increase each time. So I prefer that kind of thought out structure of the for loop. But there are situations where a while loop is the better choice, and I'm forced to use it begrudgingly. I just don't like while loops. But some programmers say you should use while loops for everything and not for loops. I like my for loops. I'm going to keep using them. They work for me. And now let's see, fill. I'm just doing a fill statement there, and then drawing a rectangle. And we'll draw it at my, let's see, 4x. So the y doesn't change, 4x plus I times 25. So the first time through, 4x starts out at 0. All right, we're going to hide the while loop so we can only see one on screen. 4x starts out at 0. And then I is 0. 0 times 25 is 0. So the first box it's going to draw is at 0 and 200. The next box it will draw will be at 0 plus, and now it's I times 25. That's 1. 1 times 25 will be 25. So it'll be at 25 and 200. And then it will be at 50 and 200, and it just keeps repeating. So when I run this, we'll see that I get a series of boxes that look like that. So here's the first one, then the next, next, as it draws them across the screen. So now the reason we have this 4x in here is this is how we can determine where the first one will draw and how they will kind of all be offset from that point. So if I wanted all of these boxes not to start at 0, but to be starting at 23. It doesn't always have to be even multiples of 5. We can choose weird numbers sometimes. So the first one starts at 23. The next one starts at 23 plus I times 25, which is 25 plus 23. So then we are now at 48. And then we start just adding on 25 and 25 and 25 and 25. Each of these boxes is 20 wide. So now it sticks them across the screen. The key thing about this is this loop is going to execute a grand total of 20 times. If I wanted it to execute more times, then I would say I want it to be 25 times. Okay. Let's see what 25 looks like. Looks like 25 is putting us off screen here. So I changed this number, and I changed the number of times or the number of items that we will end up seeing on screen. Change it to 2, I get 2. Working with classes is where we really start to have a lot of fun with our project, because when we work with classes, we're able to add in multiple copies or instances of the same object into our project. So as part of that, we can see that we have a certain syntax that we're required to follow as part of this. So as part of this syntax, we have to define a class. And then before, when we said float, or we said int, or we said boolean, these were data types or variables. When we are referencing something that we've made as a class, we end up referencing its class name right here. And then we have a variable of that type. Now, to define a class, we have a certain structure that we use. We use the word class, and then we have the name. Now, the name for a class follows all of our standard naming conventions, where letters, numbers, camel casing, but no spaces, no funky characters, and by convention, a class will always begin with a capital letter. That is convention. If you define your class with a lowercase letter, the world won't end, your program will run. No one's even going to scold you on it, but tradition within coding is that a class is defined with a capital letter as its first letter. That allows you, when you are looking through your code, to see that, oh, that thing that I am referencing is a class because it begins with a capital letter, where your variable, by convention and tradition, begins with a lowercase letter. So if we adhere to these conventions, uppercase for class, lowercase for variable, when we read your code, it makes it easier to know. And if you follow that convention, other people can read your code and not have to decipher it as with as much difficulty. So it makes sense to do that. So we define class with the word class. Then we have our curly brace, and then we'll go down to the end of it. And in this case, Sublime is giving me this nice pink highlight telling me that's the end of a class. So thank you, Sublime, for being so kind and considerate to do that. Now, when we define a class, we define certain properties. We'll call that the data for the class. Now, the nice part about this is these values, as we define them, belong to the object that we're working with. And when we use a class, we're able to put multiple instances or copies of that class object on screen at the same time. So in this case, I'm calling it a car. Now, I could put as many instances of this on screen as I wanted or was willing to type out. Until we learn about arrays, it's probably only going to be about 2. But we can put as many copies as we want on screen. So we start out with class, define it with the class name, put a curly brace. Then you're going to define the data for that class object. In this case, I have a width, a height, an x and y, and a speed, and a color. Color is a variable type we can use as well. All classes require a constructor statement. The constructor statement is where we set up or initialize all of these initial values. So now I give them all of their things. So the constructor statement is like our setup command. It runs once. Then inside the class, we add in what in programmer speak is referred to as methods. These are what this class knows how to do. What functions can this class do? And by convention, the proper term for those are methods. So the methods this object has access to are update and display. Now, these things are not hard-coded or built into processing. They're things that I made up. I could change the word update or change the word to display to anything. It could be anything I want, provided I follow proper naming conventions and all that nonsense. So these are not pre-built. If you go and look up in the processing language and look up update, look up display, you won't find these there because these are things that we will be defining for this object. So my car v1 class has a width, it has a height, it has an x, it has a y, it has a speed, it has a color. Now it updates its x by speed, and then if it either hits the left wall or the right wall, it reverses direction, and then display fills it with whatever my color is, and then it draws a rectangle at x, y, width, and height. So now, if we look up here, inside my program, I make an instance of car. Then I say car1, my variable, is equal to new, and then we have to put car v1 and some parentheses after it. We're calling the constructor for the class. So this, what happens is I say car1 is going to be equal to a new, and now we are calling that constructor. That constructor, the comment in the code here, the constructor where I say the name of the class, and so that executes those lines of code. When I say new and then reference the class, it now runs that constructor. That's how the steps operate. Then, inside my draw, tell my car to update, tell my car to display. Now if I run it, we'll see there's the car bouncing around on screen. Now I'm going to add in a second one. V1. We'll call it car1b. 1b is equal to new car v1. There. Now I can say car1b dot update car1b dot display. Now if I run it, you'll notice that I only have one car showing up on screen. When we run this and we only get to see one of the cars, it's because the cars are hard-coded to start at the same X and the same Y position. They get random colors, so we're just going to change the Y here a little bit and just say random. Just give it a random value between 1 and 300, so then they should be vertically offset, but they should start at the same X position because X is now fixed at 400. So let's see what happens. Oh look, now I have two cars. Now if I run it again, maybe they won't be actually touching. There we go. So we can see that each one has its own y. Now, what if we say, we'll give them a random speed, so each one potentially can have its own speed. Why should they move at the same rate? They're different vehicles. Now we can see they're moving at different speeds. So each instance of the class gets its own personalized, customized, one-of-a-kind set of values. Adding a third car to continue with this. All right, we'll do it the cheater method. The cheater method that is often going to fail because copy pasting code like this is always a dangerous proposition. It's fast, but it's really easy to screw up when you go. All right, so we have car 1, car 1B, car 1C here. So now when I run this, I will get 3 cars on screen. So if your homework is to do 1,000, this is probably not going to be the way to do it. You could, and you have 2 weeks in which to do it. So maybe.
But then you just raise the stakes to 10,000 like that.
All right, so I'm going to comment out my original cars here that I have just because I want to show what I can do with car V2. So car V2, the question was, can I, well then, specify an object so it shows up at a certain location on screen, and with a certain speed and everything else. So here I have said I want car V2, and I'm going to say I want you to be at this x, this y with this speed. Now, I know that because I programmed the car V2 class to be expecting to receive these numbers. I'm going to go down and go find car V2. Car V2 looks very much like car V1. Got a bunch of variables to start out with. Defining a bunch of those here. But my constructor looks a little different. My constructor has some numbers or things inside my parentheses. Car V1, inside the parentheses is empty. So in my constructor, it just runs. And when we look up here, when I said, give me a new car V1 and run its constructor, it was empty parentheses. Car V2, it's looking for a float, and a float, and a float. And I've given these names that hopefully make sense of my using temp, meaning I don't want to worry about these values after this point. Temp x, temp y, and temp speed, and then I set my x, y, and speed equal to those values that I passed to it. So up here, when I said give me a new car V2, said I want you to be at this x, temp x, this y, temp y, this speed. Which actually I'm going to switch to a 2-column view here, just so we can see it. Can. I can't. I thought that's right, I can show 2 files, not 1. Never mind. So car V2 is expecting 3 values. So I give it an x and a y and a speed, assign those here. So when we run it, let's see, car 2. And car 2 there. So that means car 2 will start at 200 and 400, and it has a speed of 10. There we go. If I had a speed of 1, now it's a green turtle. But what we can see is happening here is I can create an instance of this, but actually now have some control over where it's going to be or how it's going to appear on screen. Just have to fix some badness in my code here. And I really don't know why that was there anymore. Alright, so now we have car 2 and car 3. So car 3 is going to be somewhere between 1 and 700 on the x, 1 and 400 on the y, and it will have a speed between 2 and 5. And I'm going to make it more dramatic. It'll be between 5 and 10. So we know that this is the fast car, the other one is the slow car. So when we run it, whoop, and problem. Oh, forgot to uncomment out my variable. All right, now let's try again. So now we have slow car, fast car. And if I wanted I could make car 4 and it'd be a new car v2, and I could say again where I want it to start, what I want its speed to be, and then have another one and another one and another one. But if you want to do more than 3 or 4, this is probably not the way to do it. Now that I have my modified class start document ready to go, change the name to demo car. I'm going to add in the data for this, or the variables for this object. So I'll say float, and we'll have an x and a y and a width and a height and a speed. In this case, because you may want a speed x and a speed y, so I'm just going to make my object. It's going to be able to move horizontally. I'm not going to worry too much about, what the heck. We can say color. We'll give it a color value of C. Again, when you have variables of the same type, you can put them all on the same line. Of a different type, it would have to be on a new line. Now, inside my constructor, this is where I assign a value to each of my variables. So I can say x is equal to, and we can hard code it in, or we can give it a random value within a certain range if we're so inclined. But in the beginning, I think we'd be best served by hard coding this in. So I'm going to just tell my x I want to be at 100, y is equal to 100, and width will be equal to 50, height will be equal to 25, and speed x, I'm going to set speed x initially to 0. I just want my object to be parked and to show up on screen. I don't want it to animate just yet. I just want to go, hey, there's something there. And I'll say C is equal to color, and now we can specify my color. We can make it random, or I'm just going to say it's red. So again, we use RGB values. We use the word color, defining it, and then we put a couple values in there and call it done. That now gives us our value that we need. Now, if I run this, we won't see anything yet because I haven't called an instance of this. Also, this class object has no way to update or display itself on screen. I think we'll take care of display first, then we'll worry about update. If I set my fill color equal to C, and then I will say rect at x comma y comma width comma height. So when we do that, then we are able to have an object that we can now see on screen. Which actually I could have given it a speed because we're not updating it, so it wouldn't matter anyway. But now that my object has been created, I'm just going to get rid of a few extra returns to try and fit more code on screen. We just need to create an instance of this. So I say demo car is equal to my awesome car. Remember, variable names can be long. They don't always have to be short. we can say my awesome car is equal to a new demo car. And the constructor for this takes no parameters, so all I do is just call its constructor. My awesome car dot display. And then we call the method of this object display. So we call its display method, so that calls this and puts it on screen. And if I want to wipe my background each time. So when I do this, then I can run it and get an error message. Oh, and demo car equals. Demo car is the type, my awesome car is the value. That's silly. It's been a long day. All right, and now we can see there's my red car. It's parked, it's 50 wide, 25 tall, and it's at 100 by 100 X and Y location. Now, if I'm feeling sporty, what I can do is I can tell my, go ahead and do it on that line, my awesome car dot update. We can tell it to update. Now, update's not doing anything yet, but update is probably going to be one where I'm going to just start out with a slow value so I have lots of time to talk while it's on screen. And we can just say x plus equals speed x. And now when running this, you can see that it very slowly, consistently works its way across the screen. So that object is now updating itself. But if I made multiple copies of demo car, right now as it stands, they would all sit on top of each other. And that'd be bad. We don't want them on top of each other. We want each car to be its own entity with its own different value. We want the cars to think that they're special and that they can show up in their own special locations. Working with arrays does not have to be scary, but it does require us to just pay attention to a little bit of syntax. The core concept in an array is that it is a group of like items. So an array is a collection of things. So if we think that if I had a bag and I put a bunch of stuff in it, that bag is my array. But that wouldn't be a very organized system, because if I wanted something in that bag, I would reach in and just get whatever I happen to find. And that works, but it's not very effective if I want to somehow be able to grab a specific item. Maybe I want to grab the first item that was put into that bag. Maybe I want to grab the last item. Well, it's kind of hard to control that. But an array is a more controlled structure. It's more like kind of a filing cabinet, or a stack of papers, or a deck of cards. If you think about an array as a deck of cards, you put one card on the table, you put the next one on top, next one on top. You know the order they're in. If you want to grab the one on the bottom, you can grab the one on the bottom. If you want to grab the one on the top, you can grab the one on the top. If you want to grab the card at the 3rd or 33rd position in that deck of cards, you just reach in and count up until you hit 33 and pull it out. That's all there is to it. It's a collection of like items, a group. That's all an array is. So it sounds scary to use a big awful word like array. It has weird kind of syntax when we put it on screen. We use the square brackets, which we're not always used to using. They're not common keys that we use in a lot of our coding, unless you use arrays. But in normal typing, you never use the square brackets. So we get to use more funny characters and train your fingers how to find more funny characters on the keyboard. So an array is just a group of items. So to make it work with my demo car, I'm going to need these cars to at least kind of show up in random places around the screen, so that when I add more than one, they're kind of not on top of each other. Otherwise, I could add in 1,000 cars and they'd all be stacked like that nice deck of cards, and I'd never be able to see them. So I'll just give my car a random value, and I'll say maybe, oh, I don't know, 100 comma 400. How big is my document? 8 by 5. Oh, maybe 600. And a random y of so now they have random positions to show up on screen, and they're much more interesting if they don't all move at the same speed, but we'll leave it at, we can move at 2 for now. Eventually we'll want to make their speed different, maybe their colors different, but for the time being, each car can now show up in its own personalized, customized, one-of-a-kind location. Okay. So now, to instantiate an array, this is one part where I think processing makes it overly complex, and it's annoying. Now, an array is, as I said, it's a collection of objects of the same type. So I can have an array of numbers. I could have an array of letters or strings. I can have an array of colors. I can have an array of my demo car object. So we create it by saying demo car, and then I put in the square bracket keys, and then I give my array a name. So I'll call it my cars. I'm going to hide the original car. We're not going to use him for now. But we'll notice how a lot of the language will be very similar. Because if you notice, we had demo car, so we referenced the class. Now we have to instantiate this array, so we have to give it a value. So my cars is equal to new, and this is where I get annoyed by processing, because we have to specify the kind of objects for the second time that will be going in the array, and we have to specify how many objects will be in our array. So we use the square brackets once again, and we can reference it. Now, one thing about dealing with arrays is arrays start counting from the number 0 because, well, it's a computer. Computers like to always begin at 0, not 1. So that's how it's going to count. And I can reference the objects that will be in this array by their position. So if we think about it as a list, so when I add them, now this won't be code, this is just going to type it in, but it'd be my car 1, comma, car 2, comma, car 3, comma, car 4, comma, car 5. The first one is at position 0 in my array, so it's a list of items. My next one is going to be at position 1, 2, 3, 4. That's how we can refer to these. So to write it out with longhand, and again, this is if I'm only doing a few items, this isn't the end of the world, but if I had 1,000, this would really suck. But I can say my cars 0 is equal to new demo car. My cars 1 is equal to new demo car. My cars 2, so I think you get the gist here. As you can see, if I was trying to go up to 1,000, this would not be fun. So if you realize when you're putting in code that what you're doing is super repetitive, that's when a light bulb should be clicking in your brain going, there's got to be a more efficient way of doing this. And what I just did here, there's got to be a better way of doing this. And that's where we will learn how to use loops in a little bit, so we can just populate it quickly and easily. Because if you notice, 0, 1, 2, 3, 4. But if I look under loops, we remember that loops, they cycle through 0, then 1, 2, 3, 4, 5, 6. Oh, look at that. Being able to count like that is going to be really useful when we want to do things. Now if we say my cars, and now I didn't put a number in there yet because I'm going to then do some copy pasting here. We're going to prove this works and then get more efficient. So 0, 1, 2, 3, 4. 0, whoop, not 4. 1, 2, 3, 4. So if we look at this, we see that I construct my array, and it uses square bracket notation. So I initialize the variable, give the variable a value, specify how many items are in my array, populate each position in that list with a new car, and then my draw will say every frame, update each one, display each one. And when they run, you can see, oh shoot, I forgot, they don't bounce off the wall. Yeah. I'm going to modify my update a little bit here while you're thinking about it and say if x is less than 0 or x is greater than width minus the width of the object, speed x times equal minus 1. So now we get the bounce factor going on. Now we should be able to see. They're all moving at the same speed, but they all started at different locations. Dealing with a whole bunch of these objects on screen as we take advantage of the for loop. The for loop allows us to go through it because the for loop knows how to iterate over copies of things. So I'll leave this here while I'm typing the for loop, and then I'll fold it out and comment it out so it's out of our way. But if I do a for loop, if we remember that a for loop goes for int I is equal to 0, I is less than something, and that something is that I will explain in just a moment, and then I plus plus. And it's always important to make sure you have your closing curlies before you continue on. Sublime gives it to me in processing. You have to type in your closing curly braces. Always, always, always type it in and then up arrow back up into your code. Otherwise, you will forget them, and then you'll be like, why is it not working? And what's this? You know, it's the error message of you have a function and a function that I can't remember what it's called at the moment. So now my array has a property associated with it that I can read. Just like my car has properties associated with it, x, y, width, height, speed. These are all things we can read. Arrays, by their very nature, have a property called length. Length is how many things are in it. How long is it? In this case, my array has a length of 5. That's how long it is. It has 5 objects in that array. So now I can say my cars I is equal to new demo car. And now I can take all of these lines here, comment them out, don't need it. So now those 3 lines of code just did those 5. And one of those lines is a curly brace, which makes it even that much more friendly. But if I had 50 cars, boom, I now have 50. So when we're doing, 2, 3, 4 things in an array, okay, no big deal. 5, it's kind of annoying. More than 5, use a loop, cycle through it. It makes your life so much more pleasant because now, okay, I can do 50 cars. That's good. And now we're going to repeat that same for loop structure inside our draw function here. So I can say for I int I is equal to 0. I is less than my cars dot length. I plus plus. And now my cars square bracket I dot update. My cars square bracket I dot display. And comment out all of the other stuff. So now we can see a couple lines of code, use a for loop, know that my array has a property of length, how big is it? And now if I run this, I will see that now I have 50 cars that are, oh, did I break this? Apparently I did. Feature request of changing their color when they hit the wall, then we can just say C is now equal to color in random 255, comma random 255, comma random 255. So they're all starting out with red, and then every time one hits the wall, it will get to be a new color. Now, to get that running, I am going to not do 100,000 or 10,000 objects, but I'll maybe do 100, so it goes in a little faster speed. But also modify them so that they move at less than a glacial snail's pace of 2, and we'll go a speed of 5, which that's a decent amount. So when they hit the wall, we're giving them a new color.
They're so random, you can't tell.
Yeah.
Well, but you could tell in the beginning. They started out, but they start out. Now you could make the colors change in an incremental manner as well, where you could store a color value, and then you could progressively say subtract from it. So every time it hit, maybe they get a little bit darker, or a little bit more transparent, or a little. And so these are other ways of, if you store something, then you can modify it over time. We're storing X and Y. We're changing that over time. We're storing speed. We're changing that when they hit the wall. So we could also now have a color incrementer thing. Instead of just saying color and put numbers in there, we could have a variable, and that variable, every time they hit the wall, changes a little bit. And then that would update what their color is. So I'll just call it color change. And I'm going to start it out at 255 here. Oh, and we'll have to define color change before I use it, otherwise that will cause no end of headache. You can't use variables until you've given them a value, otherwise it freaks out. So color change starts at 255, and now we're saying color change you can drop down. Now what we can do, every time they hit the wall, instead of updating the color, we'll just say color change will subtract 25. So eventually then that value will be down to 0. So every time they hit the wall, they're going to get a little bit darker. or not. Just, oh. And then C is equal to color change 0, 0 to match what's there. So then we reset C equal to this updated value. Because color change starts at 255. We hit the wall, it drops by 25. And then we update C the same way that we're updating X by speed X, we're updating C by this new and improved color change value. You can see the changes, they're overlapping. It wasn't, well, because eventually it's going closer and closer to 0. I'll make it more dramatic. Ooh. And just trying to think. So the second instance says we'll start out at color changes 255. I'm going to go 255 minus color change. So in the beginning, this is 0. So this one is going down. This one is going up. So we're progressively going to switch between red to green with all kinds of horrible colors in between. Ooh, that's nasty. Well, we can see it's going pretty quickly because now I'm changing by 50 instead of 25s. So it's a more dramatic change, and now we can see that change is actually happening.